Hi, good day everyone. We would be starting with your 11th module for your chemistry for engineer subject. So I hope everyone is okay. So I know that we have been deferred to by the Bagyong Kinta, if I'm not mistaken with the name. But I hope everyone is safe and I hope your family is also safe as well. So we'll start with our objectives. So we have here the objective: understand how nuclear power plants work, understand and assess the local capacity to produce energy via nuclear reactions. So let's do some class processing first. So the previous discussion, I have actually asked you to know more about the Bataan nuclear power plant. Okay? So I hope some of you actually have dug down or have had questions in mind that how does nuclear power plants really work ba? Okay, so are they like you input materials and then they would be generating energy as for halimbawa hydraulic, 'di ba? You have running water, you have a turbine to convert the energy from the water to energy that's usable na. So in case of nuclear reactors, so what possible? I hope you've come to be curious about how does this nuclear reactors work as well. Okay, so we have here what's inside the classic nuclear power plant. Okay, so nuclear reactors are actually the heart of a nuclear power plant. So these is what you are referring to as the nuclear reactors. Okay, so they actually contain and control nuclear chain reactions that produce heat through physical process called fission. The heat is used to make steam that spins a turbine to create electricity. So technically, it is still using a turbine to convert the energy from from uranium specifically, or from certain high energy chemicals or elements to your electricity. Okay, so with more than for example, for with more than 450 commercial reactors nationwide or worldwide, actually 95 is in United States. So nuclear power continues to be one of the largest source of reliable carbon-free electricity available. The main job of this reactor actually is to house and control the nuclear fission. Okay? So recalling the nuclear fission, this is a process where atoms split and release the energy. Usually, we are using uranium whenever you are doing or translating or getting power from nuclear power plant. So it's typically encased in a containment structure, typically several feet thick yung kanyang confinement, and this is actually made of steel or concrete, pero sobrang thick if ever concrete. So in that way, it would keep the radioactive gases and the liquids inside. So possibly kasi there's this fear that it can actually 'di ba, in Bataan, there's this fear that it can actually damage the surroundings. Okay? So the containment actually answers that. So that's why it's very thick, it's very sealed. Okay? So reactors use uranium to nuclear fuel. So the uranium is processed into small ceramic pellets and stacked together into sealed metal tubes called fuel rods or control rods. So this is our control rods. Okay? So that uranium cubes, parang pebbles, stuck sila sa rods and then ilalagay sila sa assembly. Okay? So typically, more than 200 of these rods are bundled to ignite Okay, the fuel assembly. So a reactor core is typically made up of a couple of hundred assemblies depending on power level. Inside the reactor vessel, the fuel rods are immersed in water, which acts as both coolant and moderator. The moderator part, okay, so helps slow down the neutrons produced by fission to sustain the chain reaction and also serves as coolant as it absorbs and transmits the heat from the reactor to create steam for turning the turbines and cools the reactor core so that it doesn't reach the temperature at which the uranium actually melts. So this tube shows the liquid or the cooling water, okay, that's getting inside the system. So as stated a while ago, what actually makes this turbine work is the steam that's coming from the heat or the energy that is actually released from the nuclear reaction inside the rods of this uranium. So the steam flows into here and then it ignites the turbine. Okay, and therefore it translates into it was sent to a generator. Okay, and then the generator transforms it to electricity. Okay, so we have actually types of light water reactors. So it's actually two. We have the pressurized water reactor or the PWR, wherein most of more than 65% actually of the commercial reactors worldwide are pressurized water reactors or PWRs. So because these reactors pump water into the reactor core under high pressure to prevent the water from boiling. So in pressurized water reactor, the water is pumped into contact with the core and then kept under pressure so that it can actually turn the water to steam. Okay, that pressurized water then is brought into contact with the second supply of under pressured water, which in turn converts them to steam. Okay, and thus it turns the turbine. So this is actually the what is the same as what is shown in the previous slide. So that's called pressurized water reactor. The second type is actually the boiling water reactor or the BWR. Okay, so BWRs heat water and produce steam directly inside the reactor vessel. So as you can see here, so meron na talagang separation ng water, boiling water at saka ng steam. Tapos the rods are actually immersed in the water. Okay, as you can see here. So water is pumped through the reactor core and heated by fission process. Pipes then feed the steam directly to a turbine to produce electricity. The unused steam is then condensed and back to water and used in the heating process. So we're talking so much about nuclear reactors, but generally when you're doing something, say for example even in your process you're eating, but when you're eating there are wastes whenever you eat. Okay, that's normal. Okay, so like any other industry, any other reality, we also have wastes in nuclear reactions or reactors or our nuclear power plants. So, the use of nuclear energy results in some waste product, pero but it's not as big as others thought it has been. Okay, there are three types of nuclear waste classified according to their radioactivity. So, we have low. Okay, when we're talking about the low, that comprises 90% of the waste, which is the majority of the waste that's been generated by nuclear waste. This is composed of only light contaminated items such as tools and working clothing that is actually in contact with the processing or with the loading of materials like that. Okay, so this contains only 1% of total radioactivity. So it's very low risk if you're very much concerned with the radioactive how dangerous this materials has been. So it only contains 1%. And then we also have this so-called high-level waste. So high-level waste, which is at 3% only, mostly comprising used nuclear fuel that has been designated as waste from nuclear reaction. So it actually contains 95% of total radioactivity. So unlike any other energy generating industry, the nuclear sector takes full responsibility of all its waste. So many permanent disposal facilities are in operation for low and intermediate levels. So and the facilities for high level waste and used nuclear fuel are under implementation. Those sa atin, parang same facility yung inilagay nila. Okay? And facilities under construction. On average, the waste from a reactor supplying a person's electricity needs for a year would be about the size of a brick lang. Okay? Only 5 grams of this high-level waste, about the same weight as a sheet of paper lang, would be generated. If you would be targeting to generate that or to supply a person's electricity needs for a year, imagine that waste. That's just a sheet of paper to give a person an electricity supply for a year. Okay, so imagine the how small the waste has been for our nuclear plants. So how do they dispose the nuclear waste? So when used fuel is taken out of a reactor, it is both hot and radioactive and requires storage and water to allow the fuel to cool. So this is actually the process. So they are actually immersing it to water so that it can diminish, or the temperature can diminish. Okay, so the fuel can be kept in the wet storage or transferred into a dry facility after period of initial cooling. So keeping the used fuel in temporary storage to allow both the heat and radioactivity to diminish makes the recycling and disposal easier. These are, however, not permanent storage solutions. Two main waste management strategies exist across the world. Some countries have been recycling used nuclear fuels for decades. Others have opted to do the direct disposal. So this is fundamentally a strategic decision taken at a national level and mainly driven by political, economic, as well as technological considerations. So let's talk about the um how others actually dispose waste. Okay, so 97% of the uranium could be used as fuel in certain types of reactors. So recycling is actually the most used tool for nuclear waste. So mostly focus on extraction of plutonium and uranium, as these elements can be reused in conventional reactors. So this separated plutonium and uranium can subsequently be mixed with fresh uranium and made into new fuel rods for the nuclear fusion naman. Okay? So, if you're recycling, since nag-decrease na yung capacity, the process you'll do is nuclear fusion this time. So, since two small elements, para maging stable siya, nuclear fusion ang gagawin natin sa kanya. Okay? So, countries like France, Germany, Japan, Belgium, and Russia have already used plutonium recycling to generate electricity. So it actually reduced the radiological footprint of their wastes. So we also have this direct disposal method. Okay, so direct disposal method, the used fuel is placed in canisters, which in turn are placed in tunnels and subsequently sealed with rocks and clay. Okay, so may container, then lalagay yung rods, then pinapatungan. Okay, so the waste from recycling, that so-called fission products will also be replaced in the repository. So, though yan ay rare kasi it takes up space, okay, but some of them, some of the countries are actually using this process of disposal. So, perceived health risk. So, although we have greatly seen how advantageous it might have been if we'll be using the nuclear power plant, okay? So we have this common misconception. So because certain parts of the nuclear waste remains radioactive for billions of years, then the threat must be sustained for that period. However, in reality, this is not the case. While there is a remaining radioactive, that's weak ha, okay, for a few 100,000 years, the radioactivity from the main component of the waste, which could cause health problems, will have decayed to safe levels with a few hundred years. So the fact that the quantity of materials which would be found in the environment in the event of a leak would be very small. The amount of radioactive materials that would enter the environment would make no difference to the natural environment or the future humans. Radiation is an unavoidable part, diba? We're always hearing radiation as we're getting notifications that there will be harmful emissions of radiation. So and we cannot actually get away with that. Okay, so life is actually evolved in thriving in the radioactive environment, and the doses of the nuclear waste that would be generated from this would be almost 50 times smaller than the average background radiation that we currently have. So technically, it's safe. So I would like you to watch this video. So this is Bataan Nuclear Power Plant. This is a visit. This would probably it's like a tour, okay, in which you would be able to see how things are going inside, and with the hope that it would help you in your activity for the session. So for questions and clarifications, please feel free to message me on Teams. Let me just show you your activity. Okay. So your activity today, after knowing deeply more about nuclear reactors, I would like you to create a debate-like paper or discussion wherein you would actually portray if you're into or you're against the opening of the Bataan nuclear power plant. Okay, so in this way, I would expect you to research thoroughly, okay, and make your stand. As LACN, we have to make a stand whenever we are, even it's political. Okay, so we have a stand, but our stand must be based on facts. Okay, so that's why I would be asking you to make a presentation or make a material that is published ready, meaning this is not plagiarized, and everything is based on facts. At the end, you should be citing your resources. You can check the links for the sample of the activities that is expected to be produced by you in this activity. Thank you so much for your participation in this session, and I hope you'll have a great day. Thank you.